Here is a second example concerning expected values. You are given the choice between a certain $500,000 or $0 or $1 million based on the results of the toss of a fair coin. Which would you choose? Well, those from the previous question that were risk takers between the $0 and $10, now it's a little bit tougher because you realize that you could walk away with a $500,000 for certain if you choose A, but if you choose B, you walk away with nothing. Well, $500,000 is a real game changer in terms of your future, so you might become a risk-averse person and choose the first. We're going to do exactly the same as we did in the previous example. We're going to calculate an expected value. So you let the random variable x denote the winnings of part B, just like before. The probability mass function x still is equally likely, but instead of being between 0 and $10, it's now between 0 and $1 million. So the expected value of x is mu, is the expected value of x, is the sum over the support set, script A, of x times f of x. So you have 0 multiplied by f of 0, which is 1/2, plus 1 million multiplied by f of 1 million, which is also 1/2, and that gives you a $500,000. So in this case, the expected value of the two are the same. So in some ways you should be neutral, but if you get into a field known as decision theory or another field known as utility theory, they can sometimes help quantify this situation when the numbers go way up in terms of you leaning one way or the other. But in terms of just sheer expected value, the expected value of A and the expected value of scenario B are identical.